Hydraulic shocks are amazing and important components of modern vehicles, but are often overlooked. Out of sight, out of mind, most people are familiar with the external look of modern shocks, but the manufacturing of hydraulic shocks and their internal components are often a mystery. In a time before time, the Romans used chariots with primitive suspension in the form of leaf springs made out of wood. When cars were invented, the ride was rough and rigid. In the early 1900s, Henry Ford, a very innovative and revolutionary automobile manufacturer, created the Ford Model T. Henry Ford used a vanadium steel leaf spring developed from an Italian race car to suspend the car. This allowed for a smoother ride, higher speeds, reduced weight, and lower manufacturing cost, all while improving the durability of the car. Advancements in the manufacturing process have improved the quality, durability, and price of modern shocks. Modern suspension allows cars to grip the road better, carry more weight, handle higher speeds with stability, and absorb bumps in the road. The hydraulic shock manufacturing process begins with a sheet of steel that is cut to width and cold roll formed into a cylinder. This forms the inner and outer shock tubes. Cold formed metals can be made lighter, stronger, and more durable because a heating process does not change the properties of the metal. Once the steel is formed, it is seam welded using an electric resistance welding process. A copper wheel applies pressure and passes electric current through the material to create the seam weld. This is effective because it can make a long continuous weld and also assist the movement of the material, thus saving time in the overall production process. Spot welding is another resistance welding method used in manufacturing shocks to join other pieces to the shock body. Sintered metal is used to make the end pieces for the shock. Sintering is a process that creates solid objects from powdered metal. The powdered metal is pressed into a mold and heated to fuse the particles together. Sintering is used in manufacturing because it is a simple process that is effective for mass production and precision. A CNC machined aluminum valve and a stack of steel washers control the oil flow within the shock. After the pieces are fabricated, they are joined together using copper wheel welding. The shock is filled with a specially formulated anti-foaming suspension fluid. This helps control the shock movement as it absorbs the bumps in the road. The shaft and the valve body are then attached to the body of the shock. Once the shock is filled with suspension fluid and welded closed, it is then punctured and filled with nitrogen gas. Nitrogen gas helps the shock maintain a stable temperature during use and helps prevent the oil from foaming. Welding a steel ball over the puncture hole seals the nitrogen gas inside. Finally, the shock is powder coated with electrostatic spray paint and heated to cure the protective layer. Once cured, the powder coating forms a plastic-like coat to protect the shock from corrosion during the lifetime of its use. The final product is then quality and performance tested before it is released to the consumer. The performance data collected helps improve the quality of the product.
Research and development is an important part of manufacturing. Much of the technology seen in modern production hydraulic suspension is developed and tested by race teams in both on- and off-road applications. Because of the incredible technological advancements in suspension, new manufacturing methods are constantly required to manufacture new products such as electronically and magnetically controlled shock absorbers.
Because I'm hyped up out of control. If it's a fight, I'm ready to go.
Shock and hesitate.